Now that we've introduced the idea of a definition, a function in particular, as a way of doing encapsulation of information, we can start exploring some of the variations to them. And I want to show you one place in Python that's actually can be very handy. And that is that I can have a function definition that I can change in terms of how I want to think about invoking it. So let's start with a simple function here. This is a very simple function that says if the last argument is true, then I'm going to print the last name, comma, first name. Otherwise, I'm going to print the first name, comma, followed by the last name. And I'm going to expect those to be strings. And I've got a simple little implementation of over here. I'm going to import it into my Python shell so I can use it. But at this stage, you can hopefully look at this function and realize, given some value for reverse, I'm going to test that. If it's true, I'm going to do this, which is just a print. It's not going to return anything. If it's false, I'm going to do that. Okay? Now, here's one of the nice variations on it. First of all, that first call does sort of what I'd expect. And in fact, if I go to my Python and type it in, I can say if I do print name, and I'll do myself of Eric Grimson, and I give false as the value for reverse, it prints it out in the order I expected. I could do, by the way, the same thing. I could say print name just to show you it does the right thing of Eric and Grimson. Notice the commas, by the way, to separate the parameters, and I give it true. It would help if I can type, so I'll do it one more time with Eric Grimson and true. Now it prints it out in the other order. But here are some of the variations. I could say explicitly, give the binding to the parameter name reverse the value false. So doing it in the same place, but I can actually specify it. I could similarly, for any of the parameters, in the invocation, literally say the parameter followed by an equal sign and the value that I want. And all three of these are going to print out exactly the same thing. And in fact, so will the last one. But notice here, I've reversed the order. So if I'm not going to use this kind of formalism, I have to give the parameter in the place it expects. But in this case, I reversed it. Even though the function expects first name, then last name, I've said I'm going to have last name have the binding Grimson, first name have the binding Eric, and reverse equal to false. That's nice if I forget the order, or if I just decide I want to call them in a different way. I can do some other things here, though. I can change the definition of my function to give a default value to one of the parameters. In this case, the syntax is there's the parameter name, and I'm saying let it have initially the binding of false. And that means that if I call the function, as I do right here, without an explicit parameter passed in or value passed in for that parameter, the default holds true. In this case, I'm going to assume that reverse is false, and therefore I'm going to do this particular print statement. On the other hand, if I want to change the value of that, I need to give it an explicit value to overwrite the default value. And this is handy if I've got a parameter that normally I expect just to have a particular value, but on rare occasions I might want to change it. My invocations don't have to always pass in those values. So a nice little variation on how we pass values in to parameters of definitions of functions.